So the last couple of days, we've been talking about the symmetry identities, and there's been a little confusion on them, so I'm going to try to simplify it as much as I possibly can. Okay, first of all, we talk about how we have that first quadrant angle, and we want to represent a trig function of any angle using a first quadrant angle. Okay, and the idea behind that is if we can represent all of the angles in an entire expression or an entire equation based on a first quadrant angle, that's going to allow us to simplify things, it's going to allow us to cancel terms, and it's going to do a lot of good for us. It's going to take a big messy expression or equation and simplify it down to a much easier one to work with. Now, what we were struggling with, I think, is figuring out which case it was. Now, here's what it comes down to. First of all, you want to recognize how to spell recognize. We want to recognize the closest multiple. Okay, and whether it's 360 degrees or an odd multiple of 180 degrees. Now I'm specifying an odd multiple of 180 degrees because an even multiple of 180 degrees would be a multiple of 360 degrees, thus making it redundant. So once we figure out which one's the closest multiple, whether it's a multiple of 180 or a multiple of 360, then we think about whether we have to add or subtract to get to that first quadrant angle, okay, whatever that first quadrant angle may be. And also, we want to consider what that first quadrant angle is. Okay, that's also going to help us a great deal. Okay, once we have this taken care of, that'll tell us which case we're using, which will tell us whether it's positive or negative, or sine, or cosine. Okay, that's the nuts and bolts of it. Okay, that's how it works. Now, figuring out, let's talk first about the multiples of 360 or 180 degrees. Now, the multiples of, I'm not going to go with radian measure because we can recognize whether it's an even multiple of pi or an odd multiple of pi. I think we can handle that. But the multiples of 360 and the multiples of 180, we might not know. Okay, so having a reference sheet of these is going to be helpful for us, something we can flip back to. Now, obviously they go on forever in both directions, and we can continue adding 360 and or 180, and we can have very, very large positive or negative numbers. But I'm going to give you some of the basic ones. Obviously, there's 360, okay, 720 degrees, 1080 degrees, 1440, 1800, and 2160 degrees. And if you're seeing numbers bigger than that, that's just excessive. And now the multiples of 180, which are going to be between each of these, again, obviously 180 degrees, 540 degrees, 900 degrees, 1250 degrees, 1620, and 1990 degrees. And again, anything greater than that is just excessive. Okay? So, first thing that we want to do, we're given some angle, whatever measure it may be, we want to figure out the closest multiple, whether it's closer to a multiple of 360 degrees or 180 degrees, whichever one it's closer to. Then we want to consider, are we adding to get to that angle, or are we subtracting from that multiple to get to that given angle? Once we have that, we can determine which case it is. Now, the cases refer to which quadrant the angle is in. Okay, now it's not as simple as case 1, case 2, case 3, and case 4. I wish it was, but for whatever reason they decided to number the cases differently. Okay, case 1 is in the first quadrant. Okay, and that is the first quadrant angle plus some multiple of 360 degrees. Okay, and in the first quadrant, we know that sine is positive, and so is cosine. Okay, and then everything after 1 is all jumbled up. Okay, there's case 1, here's case 2. Okay, case 2 is all the way down here. And this is where you have the first quadrant angle plus an odd multiple of 180 degrees. Let's say 180n. And we'll say k is even and n is odd. Okay, just for our reference to make it a little bit easier for ourselves. Okay, now in the third quadrant, okay, y and x are both negative, which means that the sine is negative, and so is cosine. Okay, then for whatever reason, they decided case 3 was going to be in quadrant 4, and this is where you have 360 degrees, or excuse me, a multiple of 360 degrees. I guess k doesn't necessarily have to be odd, or excuse me, doesn't necessarily have to be even, but we'll specify that n is odd. Okay, and instead of it being plus our angle, it will be minus that first quadrant angle. Now in that fourth quadrant, sine is negative, but cosine is positive. Okay, and then lastly, in that second quadrant, finally we get to case 4, which is where we have some odd multiple of 180 degrees minus the first quadrant angle. Okay, now in this quadrant, our y is positive and our x is negative, which means that the sine is positive and the cosine is negative. Okay, so this is kind of our reference sheet. Okay, we flip back to this when we're working through the examples, work through one piece at a time, and that's going to help us rewrite the sine, cosine, tangent, any trig function of any angle based on a first quadrant angle. Okay, so first off, let's start with the sine of 665 degrees. Okay, so 665 degrees. And like I said, guys, I'm going to focus on degree measure today instead of radian. I'm pretty sure we can determine which is closer, an odd multiple of pi or an even multiple of pi. We can do those. But the degree measure might be a little trickier. So we have 665 degrees, and we want to see which one of these measurements it's closest to. Well, it's between 540 and 720. Which one is it closer to? 665, closer to 720 or 540? It's closer to 720, so it's closer to a multiple of 360. So I have 720 degrees. Am I adding or subtracting to get to that 665? I'm subtracting. Okay, what am I subtracting? What am I subtracting to get to that 665? Katie? 55 degrees. Okay, so I'm doing a multiple of 360 minus that first quadrant angle. That's case 3. And in case 3, sine is negative, cosine's positive. So that tells me that the sine of 665 degrees is equal to negative sine of 55 degrees. And with an expression like that, I might be able to simplify a larger expression that might help me solve a larger equation, a whole lot simpler than dealing with the 665. I might be able to cancel terms. I might be able to combine terms. Okay, and for another one, let's say we have cosine of 480 degrees. Okay, let's look at that 480 degrees, and let's compare it to our multiples. Okay, it's between 360 and 540. Which one is it closer to? Okay, we have 480 degrees. Is that closer to 540 or 360? It's closer to 540. Okay? So I have 540, which is a multiple of 180 degrees. Okay, am I adding or subtracting to get to that 480 degrees? Subtracting. Okay? Which tells me that I'm dealing with which case? I'm doing a multiple of 180 degrees minus a first quadrant angle. That's case 4. Okay? Okay, now, what is that first quadrant angle? What am I subtracting to get down to that 480? 60. Oop, not, yep, sorry, 60. Had a little brain fart for a minute there. 60 degrees. So the A is going to be 60 degrees. Okay, now, in case 4, we're dealing with cosine. In case 4, cosine is negative. Cosine changes sign. So that means that the cosine of 480 degrees is equal to negative cosine of 60 degrees. Okay? So again, we look at what that first quadrant angle, what multiple of either 360 degrees or 180 degrees we're closest to, whether we have to add or subtract to or from that multiple, and what that first quadrant angle is. Okay, and we put all those pieces together to figure out whether we're keeping the same sign, S-I-G-N, or if we're changing positive and negative. Okay, so let's look at another one here. Let's look at the sine of 475 degrees. Okay, so 475, that's the magic number. Okay, so let's look at our multiples. 475, it's between 360 and 540. Which one is it closer to? Closer to 360 or 540? Brendan? It's closer to 540. Okay, so 540 degrees. Am I adding or subtracting to get to that 475? I'm subtracting again. Okay, and what am I subtracting? What am I subtracting to get down to that 475? 65 degrees. Okay, so I've got a multiple of 180 degrees, and I'm subtracting from it. Which case is that? Ian? Case 4 again. Okay, and in case 4, talking about sine, does sine stay the same or does it change? Stays the same. So that means that the sine of 475 degrees is equal to the sine of 65 degrees. Let's be consistent. There we go. Okay, last one. You guys talk me through this one. Okay, let's say we have the sine of 220 degrees. Okay, so let's talk sine of 220 degrees. So the magic number is 220. Okay, let's look at our multiples. Can you tell me what to think of from here? Very good. It's closest to 180 degrees. So I have 180 degrees, like you said, plus that first quadrant angle equals 220 degrees. Okay, now what? Okay, that A is 40 degrees. Okay, now someone new. What comes next? What do I think about now? Okay, this one's going to be case 2. I have a multiple of 180 degrees plus that first quadrant angle. That's case 2. Okay, and what does case 2 tell me about that sign? It's going to be negative. Okay, so it's negative what? Sine of 40 degrees. And, okay, so we figured out a process here, a step-by-step process. First, we figure out what multiple it's closest to, figure out whether we have to add or subtract to get from that multiple to the given angle. Then use that, whether we're adding, subtracting, whether it's a multiple of 180 or 360 degrees, use that to figure out what case, which implies whether it's going to be positive or negative for sine or cosine. Okay?